We're now going to go over the air calibration process for the Gator DPS setup. With this test, the purpose is to eliminate any noise from the signal, so when the sensors are properly set up in the apparatus, they'll be able to pick up the reflection coefficient of the asphalt, calculate the dielectric, and give you an accurate air void measurement. So for this, with the Gator setup, what we do is actually just set the sensors upside down on the pavement so that we don't have anything within the immediate radius when we're doing this air calibration. These signals will, at the end of the day, be subtracted from the signal when we're doing the dielectric measurement. We're now moving on to the metal calibration portion, and in this case, for the Gator, we need to make sure that the sensor height is at the intended 9-inch height above the tested asphalt. With the cart set up, it's already going to automatically be at the correct height, but with the Gator, we need to make sure that we're at that 9-inch height using the hydraulics here. So what we're doing here is Ralph is sitting in the position he's going to be during testing to make sure any sort of suspension isn't affecting our height. And then I'm just simply going to check the height here, and we're sitting at about 9 1/4 inches. So we're going to go slightly down. Ralph, go ahead and put the lift slightly down. Good. And now we're at our intended height, and you can double check with the other sensors just to make sure. And at this point, you're ready to start your metal plate calibration. We're now ready to move on to the actual metal plate calibration measurements, and you need to do this with all 3 sensors. Right now the screen is showing a green highlight on all 3 sensors. We've chosen to start with our rightmost sensor here, which is sensor 173. What we've done here is made sure the laser is centered on the center of the plate, which is easy to see because there's a little hole in your plate where you can line that up. And once this metal plate is centered where you want it, you go ahead and press that green button. So Ralph is now going to press the right green button, and that will do its job until it's done collecting its measurement, and then now that button will no longer be green. So Ralph's going to tell me when that has completed. All right, so now I'm going to take this plate and move it to the center sensor. Make sure that it's lined up at the hole location. Make sure that it's relatively square to your sensor. And notice Ralph is sitting in the same position he's going to be during the field collection. We just do that to make sure the sensor height is going to be consistent. So go ahead and press the middle button, Ralph. And Ralph will let me know when that measurement is complete here, and then I'll move the plate to the final calibration location.
Good.
Okay. Now that this one is ready to go, Ralph's not going to press the button yet because we're now going to zoom in and show you exactly how the laser looks. Okay, we're now ready to do a zoomed in view of what this metal plate calibration looks like. We just wanted to show you or highlight here that there's actually a green laser coming out of each of these sensors, and when you're in the correct spot centered on the plate, you should actually see that green laser in the dot in the middle of your plate. And this is a critical thing to do to make sure you get the full reflection from the sensor on that day, and that'll give you a very highly accurate dielectric measurement if you do this properly. Okay, so now Ralph is putting in our current starting station number. So in this case, we're at station 39 plus 00. So he's just keeping 39 on our station number and starting station distance at 0. Looking up station, we're in the left lane, so that's why he has left here. And because we're doing a calibration, we're putting the offset at 25. This is our quality assurance type measurement. We're doing a swerve, so we're putting 25 in here for our offset. And then we are on the left lane relative to the center line offset. MnDOT is doing this type of a convention to help us with our Beta input, where we basically have the month, day, year, dash, route, dash, pavement type, which is HMA in this case, the left extent of the lane, which is left 12. Oh, sorry, the next one is our lift, which is lift 2, L2, dash, left extent of our lane, which is 12L, and right extent of our lane, dash CL, since center line is our right side of our measurement. And we just repeat that for our file name unless we were to change the lift or lane that we're currently in. Typically that stays the same for the whole day, and then the software automatically appends 001, 002 as you go throughout the day. And you can put anything you want in the comments. Today we put video day because we're shooting our training video. This is an important thing. If you do your quality assurance measurement, we always want to export it to our field measurements so that you can also use your swerve data as a MAT random assessment. So Ralph is going to press collect now in the software, and it'll have a short warm-up period, and he's going to select swerve because that's the test we're going to complete, and he's going to put the measured distance, which is typically 500 feet. Press enter, and you can actually press any of the 3 sensors for this test. And now we're ready to do our swerve calibration, where we're testing to see if there's any bias between our sensors. We're now ready to do our swerve quality assurance of our dielectric bias between our sensors here. And Ralph is actually going to start the Gator bracket to move side to side before he even starts to move forward. So go ahead and do that, Ralph, and start the bracket moving side to side. We're going at about 10 inches per second here, and we're trying to move very slow as we go along to minimize our distance between points in the stationing direction. So go ahead and start your swerve pass, Ralph. So Ralph is just trying to go at a very slow speed here, and we're getting full lane coverage that we can use for our MAT assessment. And the other thing we're doing here is we're getting a lot of overlap between our measurements. So when you do the swerve pass with the cart, what you end up doing is going forward for 500 feet and then back for 500 feet to make sure you have full overlap between your outside most sensors. In this case for the Gator, it's easier to just do a single direction swerve. So we're actually going to supplement this with a static transverse pass that we'll show later. So as you see the Gator moving back and forth, you'll notice that the rightmost sensor is actually going all the way to the joint, and we have it programmed so that the leftmost sensor is going all the way to the 12-foot lane extent. So in this case, depending on the speed Ralph is going, we actually have a measurement at set spacing in the stationing direction as he goes along the pavement. And he'll continue to do this with the sensors going back and forth for a total of 500 feet. And then we'll take a look at the results. Okay, the swerve calibration has been completed here, and what you can see is that our rightmost sensor is measuring higher and our center sensor is measuring lower. This is the reason you have to do these sorts of calibrations, is because you want to eliminate bias between your sensors. Okay. Okay, once we've completed our swerve and transverse line quality assurance measurements, we're ready to move into field measurement. So we just do that by grabbing the drop-down menu there, keep the collect mode at distance because we're just collecting based on the DMI. And for the starting station number, if you have corrected GPS and an alignment file, you can actually just read it directly from your screen here. You won't be able to see it on the video most likely, but we have a station output here that's 44 plus 37. So we're going to actually put that into our starting station location, and that location is directly where we are, station and offset minus 6.28. That is where our receiver is within the job site according to the alignment file. So because we have that output there, we don't have to be at an even stake location. We can just say starting station number 44 and starting station distance 37. We're going in the increasing station direction, so we have this unchecked. We're in the left lane, looking up station to the left, and now instead of 25, which indicates that it's a swerve pass, we're going to put a 6 because we're centered at 6 feet away from the center line. For Gator calculation, we're still going to run our sensors back and forth so that we can get the full collection lane width. And our cart position relative to reference line is left, and we actually do keep our lot and file name designations the same as explained before. So now Ralph is ready to collect in his normal field measurement arrangement. So now if the sensors are not already employed to move back and forth, Ralph is actually going to go start those sensors moving back and forth, and we'll take a look at that in a little bit. But for now, we just want to show the data coming in as Ralph moves at a relatively slow rate forward along the pavement. So you can see the station and then also the data coming in here as the sensors are moving back and forth. And this will be the screen that Ralph will see indicating the high and low spots from the dielectric as he collects along the pavement today.